Good day, everyone. My name is Naveed. I'm working as an associate professor at the Department of Computer Science, University of Sharjah, UAE. I sincerely apologize for not being able to attend the conference in person due to visa issues. Now we are also having airspace closure issues that make travel planning almost impossible, regardless of visa. I'm really sorry for any inconvenience in this regard. Today I'm going to present a research paper, Perceive, Adapt and Interact, an intelligent virtual agent for education in mixed reality. This is done together with Ms. Zuleha, Dr. Mohammad Lataifa and Imad Afuni in our Extended Reality and Metaverse Research Group at Sharjah University. All right, so let's start with the motivation of our work. So the main motivation of work was that how can we transform the classroom experience by incorporating both mixed reality and AI? As we know that the new wave of AI threatens to replace most of the tasks traditionally performed by humans. So one of the questions we asked ourselves was, what will it take for the AI to replace instructors in a traditional classroom? So for example, can we replace ourselves with AI or not? So this leads us to first investigate the use of mixed reality for education. And as we can see that mixed reality integrates both physical and digital learning spaces. And nowadays it is easier to deploy in a classroom because of the classes can easily be distributed to students. And it has clearly shown higher level of engagement and enhanced learning experience. AI, on the other hand, can truly act as a guide to students, personal guide. We are already starting to see how AI is being employed by a student in the university in solving all types of problems. In fact, nowadays the first choice for students is to first consult an AI agent whenever they face any problem, which is causing real issues in their actual learning. But this is a different issue, completely different issue. So our goal was to integrate AI and mixed reality to create a personalized teaching assistant for students in a traditional classroom. We specifically targeted a lab setting, and we looked at the current research for employing Intelligent Virtual Agent, or IVAs for short, for embodied guidance, but identified some research gaps. Specifically, the research gaps we identified was that existing IVAs provide a very scripted experience. They do not have a good understanding of a student's environment and actions. They are passive and they cannot interact with the real world similar to a human teacher. So this identifying these research gap motivated us to develop our solution. So our approach was to give it a three-step solution. The first one was perceive. So IVA can not only perceive a user's physical environment, but for example, it should be able to navigate around and move to a physical space closer to a student, but should be also be able to understand the questions coming from the student and dynamically adjust its guidance based on the progress of the student. So it can adapt. And finally, it should also be able to interact with the physical space in some way while it is guiding the student. So three key things: perceive, adapt, and interact. Understand the user's learner's environment, dynamically adjust the guidance based on the progress, interact with the real world entities while teaching. Okay. So our system architecture is as follows. User initiates the interaction with the agent using natural language prompts, and the agent itself has a visual representation in this augmented world, and it can not only communicate orally, but it also can, use physical gestures to complement their speech. We also implemented a cognitive model for the agent that can utilize both vision and language capabilities of a large language model that analyzes users' prompt, recognizes what's on the screen, and understand users' action and generate appropriate response that goes to the speech manager for the synthesis to synthesize the voice of the or the speech of the agent, which is communicated to the user. And finally, we also have a perception system that employs spatial mapping of the scene and real-time scene understanding with localization within the three-space real-world coordinate system. This allows for the agent's navigation and actions that complement the agent's speech. For example, pointing to the right actions on a student's screen. We use different technologies to implement this system. It is an integration of, for example, for the mixed reality system, we use Magic Leap 2, Unity for implementing the mixed reality application with the agent visual representation and animation, ChatGPT LLM as ChatGPT 4o as the LLM for the cognitive model, Google Cloud Vision for the perception system for scene understanding and localization, and finally the Meta Speech SDK for voice generation for the IVA. The application scenario that we implemented to evaluate, it's a Scratch programming scenario using the IVA, which is the part of the basic intro to IT course syllabus at our university. It is a required general education course for all students at the university. Scratch as a problem solving tool is introduced in this course for a few weeks so that student can gain some basic understanding of problem solving and programming. The basic workflow as follows: student launches the application and it scans their environment. This initiates a perception module. IVA appears and introduces itself as a teaching assistant. A student requests the help with their Scratch programming using their voice. IVA walks through the student and analyzes their progress on their workspace. Then IVA provides guidance by speaking and pointing to the different block categories on the screen. A student continues coding and requests help when needed. It's also dynamic. There is no scripted sequence here. So here's a demo of the application. It will give you a good idea how it works. So a student starts coding and tests independently. If the game, for example, does not run, if there is any error, they can call the IVA, spawn the IVA, and then IVA takes over. You can see it will walk to the user and then it will communicate and help them in any case. So here, student tries to run the code, it doesn't work, so it spawns the teaching assistant for help.
Hi, I am your teaching assistant. How can I assist you?
Can you please help me fix my code in Scratch?
Please look at the screen and confirm so I can analyze your code and provide corrections.
Confirm.
You've added most blocks needed, but the greater than block is missing in the if condition. Insert it and input 150. Then, look at the screen and confirm.
Confirm.
You've added the when green flag clicked, forever, move 10 steps, next costume, and stop all blocks correctly. Add X position for motion in the if condition. Then, look at the screen and confirm.
Confirm.
All required blocks are correctly added, including stop all and X position. Great job. To run your game,
All right, so now you can see that the game runs successfully and everything works fine for the student. So the two research questions basically we are trying to answer in this work are: to what extent can an embodied IVA complement the role of a human teacher in mixed reality learning environments? The second question is: how is the IVA perceived compared to the less interactive or non-embodied system in usability, acceptance, engagement, and value? So we ran a user study in a university, 24 university students, 12 male, 12 female. It was a within a subject study with randomized order. We had three systems. The first system was a basic ARQs, only visual guidance. The second one was a chatbot, ARQs, conversation with text with some visual cues. Finally, the IVA system, where you have conversation, visual gestures, visual representation of the agent. The task was to build a simple Scratch game. Sprite moves and says hello. What did we measure? We did the quantitative measures, task time, technology acceptance model, system usability scale, user engagement, perceived value. And in the qualitative side, we got the feedback from open-ended survey questions. So the results showed that in terms of task completion, IVA took longer all the time. System usability scale, IVA scored the highest. Technology acceptance model, it was comparable across all systems, but the strongest correlation for IVA between different dimensions. Engagement, IVA higher in most dimensions, and internal consistency, stable experience with IVA. Perceived value, IVA score highest in overall value. In terms of qualitative feedback, basic ARQs were the simplest. Lack of feedback caused some confusion for the students. Chatbot was balanced, effective conversation, but it was quite text heavy. IVA was closest to real life teacher, more engagement. It resulted in more awareness. So the two research questions: complementing the role of a human teacher, IVA enabled teacher-like interaction through speech, gestures, and spatial guidance. Longer task time reflected richer engagement. It was validated through qualitative finding, closer to real classroom support than other systems. Research question number 2, usability, acceptance, engagement, and value. IVA showed comparable usability and acceptance with highest system usability scale and strongest STEM relationships. Engagement and perceived value favored IVA. Finally, In conclusion, the multimodal IVA integration, perception, adaptive behavior interaction with learners and their physical space. So we presented the system. Context, it provides context-aware guidance through conversation, navigation, and gestures. It's implemented and evaluated the IVA in an educational scenario using a Scratch programming system. It is a modular and platform independent framework. It can be extended to any type of application and deployed to different type of devices. So in future work, we want to measure objective learning outcomes with IVA and explore multi-user collaborative learning experience. Thank you very much. Sorry, I had to rush a little bit in the end because I ran out of time. But yeah, if you have any questions, you can please contact me by email and I'm Sharjah, AC.E. I hope to see you at some other conference. Thank you very much.